Okay, so we want to look at some basic circuits. We're not going to get into complex details. If you want to study complex circuits, take Physics 1112 or Physics 2212, and then you can actually go through and kind of see what's going on with these more complex circuits. So just want to look at some basic circuits here. So I want to look at a power supply. So we'll have a battery, and I'm going to have a 6-volt battery. Again, this V is equal to volts. And I'm going to hook it up to one light bulb. So I have a complete circuit. Now I'm not going to be really worried about the direction the current's flowing out of the circuit. The current's going to come out of the negative end and try to go into the positive end because the electrons are attracted to that positive end. But I'm not really going to focus on details as that. But I'm going to have an electron coming out because remember our current is a flow of electrons, and that electron is going to have on its backpack 6 volts. So it's going to be full of 6 volts of potential. And it's going to chug along, so I still got the same electron. Now there's millions of electrons flowing through here, and that electron is going to get to this light bulb, and it's going to know through electric potential that there is an electric field, that there is only one light bulb in the circuit. So because there's only one light bulb in the circuit, this electron that's carrying 6 volts is going to dump all 6 volts into this light bulb, and the electron, once it leaves the light bulb, is empty. So it's going to head back to the battery to refill. So it's going to come back here, go through the light bulb, pick up 6 volts, reload, and you're just going to get this continuous flow of current. So the light bulb is going to use that 6 volts, okay? And it's going to take that electrical energy, so it's going to take the electrical energy and convert it to light energy, okay? So it's going to take all 6 volts. Now let's look at the same circuit with a small twist to this. So we have a 6-volt battery, and now instead of one light bulb, we have 2 light bulbs, and we have the same electrons coming out. Their backpack is filled with 6 volts that's coming out of the battery. So when it gets here, it has 6 volts in its backpack, but it knows there are 2 light bulbs in this circuit. And we're going to assume these are identical. Again, if we want to do some more complex circuits, then we'll do those in 2211 and 1112. Or you can, I may post some videos so you can study that if you're interested in looking at more complex circuits. But if we're looking at this, the light bulb knows that there are 2 light bulbs coming up. So it only dumps 3 volts there. So when the electron is here, it has a backpack of 3 volts. Because it dumped 3 volts off there, and it's going to dump the next 3 volts off into the second light bulb. And this light bulb is blank. And then it's going to go back to a blank light bulb. And it's going to go back and refill. And then similarly, let's look at what would happen if we had 3 light bulbs. Sorry for my poor drawings here. So we have 3 light bulbs. Again, the battery is going to release electrons that have 6 volts in their backpack. When it gets here, this electron has 6 volts, but it knows that there are 3 light bulbs coming up. So it's only going to release 1/3 or 2 volts. 1/3 of the 6 volts. So it's going to release 2 volts here. And then when the electron is here, it has 4 volts remaining. And then it's going to dump another 2 volts here, another 2 volts here. So again, at this point, the electron has 2 volts. And then here, the electron's backpack is empty. And then it goes back to the battery to pick up more energy. Now, so we're looking at this, and what happens is the electron knows what's coming up, knows how to release the voltage. And if you look at this, all the light bulbs are in series. So the light bulb, so there's only one circuit. Or, in a lot of cases, there's one wire, I'll put that in quotes, connecting. So as you go around, you can make one loop, One loop. So they're all in series. They all flow one after another. The wire or the green loop never splits. And you'll see where it splits here in a little bit. So we can kind of go through and we can see what's going on here. Now let's look at parallel and where they're going to split. So let's look at a circuit. So here's our battery, 6 volts. It's going to come down and connect to one light bulb. Again, this looks very similar to where we just started up here, but I'm going to connect another light bulb here. Okay. So the electron, when it leaves the battery, still has 6 volts in its backpack. Again, that potential that the electron is carrying is determined by the battery or the power source. And when it gets to point A, it has a choice. It can go to the green path. And highlight this. It can go to the green path, or it can go to the fuchsia path. Okay? So it has a choice. So the electron has a choice of what path it wants to go. So let's say it goes this direction. Well, the electron still has 6 volts. And it knows, as it's going around, it has one light bulb to deal with, so it's going to dump 6 volts into that light bulb. And then when it leaves the light bulb, it has 0 volts. But another one of its friends wants to follow the other path, so it's going this way, and it has 6 volts. And it knows that it has one path, so it dumps 6 volts here, and when it leaves, it has 0 volts. And it works its way back. But what happens at point A? So at this point right here, the wire splits. And we get a parallel circuit. Okay? So we're going to look at these, what's going on here and how these things are actually splitting, and we're going to use Ohm's law to analyze what's going on. So what happens up here on the series, the electrons had no choice. So the electrons here had no choice. They had to go through both light bulbs. The electrons here had no choice. They had to go through all 3 light bulbs. Here, the electron has a choice. It can follow the green path, or it can follow the fuchsia path or pink path, however it's shown up on your screen. But it has a choice. So at A, it has a choice of going this direction, or it has a choice of going this direction. So the wire splits. So part of the current goes green, and part of the current follows the fuchsia path. So we want to look at, well, what is this current? And that's where Ohm's law is going to come in. So Ohm's law is V is equal to I times R. And that is our voltage or our potential is equal to our current times our resistance. And our units is V for volts is equal to I amps times R ohms. And our letters, so our units will be V is equal to amps times the Greek letter omega. So ohms is the Greek letter omega, A is the Greek letter, is the letter for amps, and V is for volts. So here is our circuit. V is equal to I times R. So let me just redraw the circuit. So let's look at, we had a mess up there. 6 volts, and let's say that we have a 60 ohm light bulb. Okay? And I want to find current. So I have V is equal to 6 volts. My R is equal to 60 ohms. And I know that 6 volts is dropped off here. So going back to our picture up here initially. So we have V is equal to I times R, and I want to find I. So I get 6 volts is equal to I times 60 ohms. And then I is equal to 6 volts over 60 ohms. where I is equal to 0.1 amps. Well, let's do one that's similar, 6 volts. Let's do the double one. So we know that if this is a 60 ohm, we went back, we know that this is 3 volts here and 3 volts here. So if I do V is equal to I times R, I get 3 volts is equal to I times 60 ohms. So my I is equal to 0.05 amps. Let me back up. So I skipped a step here. Sorry about that. I is equal to 3 volts over 60 ohms. And this is half of this. Well, it makes sense because now, if you look at this, I have an R equal to 60 ohms, R total. Here I have two resistors. So my resistance adds, where I get 60 ohms plus 60 ohms. So my total resistance is twice as much. So if I have twice as much resistance, I'm going to have half the current that's flowing. Think about a dam. If it's twice as big, you get less water flowing through. So I got 2 times the resistance, and we'll get half of the current. Now this is only true for series circuits. Well, what happens with these parallel circuits? And I know this is a longer video. I don't want to get all of these topics into one video. So I have 60 ohms, 6 volts hit that circuit, 6 volts hits this circuit, and it's going to be the same calculation. Our current is equal to 0.1 amps. So our green current, hold on, let me color code this. Our green current is 0.1 amps. Our fuchsia current is 0.1 amps. So let's think about what's going on here. I have 0.1 amps here coming into this point, and I have 0.1 amps here coming into this point. Well, if I have 2 wires, let's look at these wires bigger. I have 0.1 amps coming in and 0.1 amps coming in. Imagine if I have 2 rivers, and I have this water flowing this direction and this water flowing this direction. Well, they're going to combine and make a bigger river, correct? So what happens is I have 0.1 amps plus 0.1 amps flowing through, and I have, at this point right here, 0.2 amps flowing into the battery. Okay, so you can look at each light bulb individually, find the current, and then think about what's happening with those electrons. So remember we talked about how with the electrons, part of the electrons follow the green, part of the electrons follow the fuchsia, but as a whole, they're going into the battery. Okay, so hopefully this goes through, and we'll give you lots of practice using Ohm's law. So kind of make sure you know how to use it, because a lot of you are going to be using it in future courses and in your life as well.